Thank you very much, Yu, for your wonderful presentation. The presentation is now open for questions.
Hi, Professor. Eu gostaria de saber se essa cerâmica já foi patenteada e se ele poderia comentar o processo de fabricação.
Okay, he wants to know if you have do you have the patent for this graded material, Yu?
Yes, we do have one, but I'm also open for discussions. I'm all right
no,
to
and
answer your question.
the other thing that he wants to know is how do you produce the graded material? What's the production?
So it's we use glass ceramic infiltration technique, and the key is now you have to come up a glass composition has the coefficient of thermal expansion matches up with your target materials, whether zirconia or alumina, right? Because otherwise you introduce thermal stresses into the system. So what we do is you can do two ways. One is you can lightly sinter your material, infiltrate in glass into it, like now in ceramic material. But you can now almost densify the material. You're still able to infiltrate it. And that will give you a very thin graded glass ceramic layer on the surface. And that's what we're doing here, trying to show you that you can almost infiltrate very dense materials.
No momento que infiltra o vidro na face interna da coroa, por exemplo, será que não pode causar desadaptação?
Can you have a problem of misfit because you are infiltrating the glass in the inner side of the crown? That's his question. Is there a problem of adaptation because of the...
Very, very, very good question. Now, you know that you will have a residual glass layer about 20 micron to 50 micron thick, right? You have some glass there. So there are two options. One, you can dial in when you do this CAD-CAM it, you give it the lead way for this, or you can etch it. After you infiltrate it, you use HF to remove the majority of the glass. That gives you a rough three-dimensional surface for cementation. Yeah. Theoretically. Or alumina, alpha alumina. Thanks for the collaboration. So this is going to be a tough question, is it?
No. Zhang, it's a practical question. But let's say that you have a 2 millimeter occlusal clearance. My question is, would you build an anatomical crown with a graded structure and a very thin external glass as I've seen from your picture? Or would the graded structure plus the veneering ceramic, would the veneering ceramic finish the anatomy? Because my concern is due to potential occlusal adjustments. If that wouldn't, for example, eliminate the graded structure and expose the underlying zirconia.
Arguably, you can veneer them. And in fact, many people pointed out the translucency of the graded zirconia is not going to be good enough, because the bulk of the material is zirconia. What does 100 micron on the surface glass gonna do to the translucency of the material? So if you want to veneer them, then we haven't done this. I mean, test the bond strength. We did veneer them, but I will think that now you are a lot easier for porcelain to fuse onto this porcelain-like glass on the surface.
It's a different kind of question. I remember 2 years ago, I think, when I first saw this presentation, and I asked the same question about the fabrication. You're not able to answer.
Back then, I wasn't.
And I'm glad you answered it now, because you're very curious to realize what is actually going on in there, and it's really interesting.
It
So
takes a
congrats
long
again.
time for the patents to go.
Yeah, I understand that.
The unfortunate case.
So the question is
time.
actually from a different perspective now. From your slides, I could see that you're using a material that doesn't have perhaps the same viscoelastic properties than dentin. And one of the things that we recently found, and I know you saw the presentation in New York, where the dentin is able to recover quite a bit of the strain that is applied due to contact, such as the ones that you're applying with a different load, of course. But you think you would have a different type of behavior under these loads that you're applying, even if it's sliding or just a static load, if you have a material that has a viscoelastic behavior that is similar to the actual dentin, particularly in cases where you have a lot of water flowing around and things like that?
Yes, that's a very good question. Now, remember those fatigue tests and a single cycle loading test, we use two kind of substrate supporting materials. One is polycarbonate. It's much less stiffer than less stiff than the dentin. The elastic module is about 3 gigapascal, and dentin is about in the 16, 18. The other set of material we do sort of fatigue alumina, zirconia, and graded structure. We use C100 composite material. Now that material has a elastic modulus very similar to dentin. So we already take the consideration of the supporting material that's viscoelastic.
But my question is,
Yes.
definitely the elastic modulus is quite similar. But the thing is, when you add water to that system, when you have collagen fibrils and structures such as glycans, aminoglycans, and proteoglycans that depend a lot on the electrostatic interaction in the presence of water, and you have that water floating around and everything, the viscoelastic behavior is quite different than if you actually have a polymeric chain that is all bound together by several interconnected
Excellent
bonds and things
question.
like that.
So what we did was when we make those substrates, we soak them in water 37 degrees for a month. That I didn't mention. And Esteban did those tests too. So that's our lab standard protocol. So those dentings sit in there because Van Thompson is sort of cement denting guy. And he said, oh, you got to let it soak up with the water. Otherwise, you cement them on and put in the water to test it, then suck up water, give you stresses. So that's where we soak them in to saturate it. But, of course, still will not be able to mimic the denting because you now have those the organic other phases in there. But we do have water in the system and sucked into the polymer support, as well as when we do the test, the whole thing is immersed in the water.
Because you'd be interested if you could actually match the stress resistance that you're able to provide with this graded interface that you're creating with the ability of the dentin matrix to recover from that strain that you're applying. If you're actually able to match that exactly, then you can prevent that initial failure, which would be just
Very,
great.
very good point. We haven't looked into that yet. That's a very good point. Thanks.
So near the beginning of the presentation, you showed, if I understood correctly, on the fatigue loading, the heaviest load on the normal zirconia lasts only 30 cycles or so, and this is as opposed to the clinical case at much lighter load, which lasts for a very long time before failure. So I was wondering, do you think there's a possibility in that heavy load changing the ratio of the crack growth mechanisms? For example, changing the contribution of stress corrosion versus water pumping?
That's possible, but I can't recall that we loaded zirconia initially. It was glass. As you're talking about the video we show, 30 cycles, you're sliding across versus normal non-friction loading. That was glass, and it was 120 Newton load. We didn't load zirconia initially, because the only reason we use glasses serves two purposes. One is transparent, so you can see the fracture evolution sequence in the material. And the second issue is now we can compare. You have a friction without friction, how much difference it's going to have in terms of damage modes as well as the cracker propagation rate.
Do you think that the contribution of the friction versus the other modes changes when you do the overstress acceleration?
Yes. And I didn't show here. I think I showed you briefly. And when you have a friction on the surface, the tensile stress at the trailing edge of the moving indentor, if you only have 0.25, friction there, and the coefficient there, can boost the tensile stress by a factor of 4. If you get up to 0.5, it's almost 5-6 times more higher stress. So the material is now experience a very high tensile stress if you have a high friction on the surface. That's the surface stress analysis. I did it with Brian Long.
Okay, when Bob was talking with me after the last presentation, I got distracted because I'm receiving questions from the internet. So I'm going to ask the question from Rodrigo Assunção, who is in Rio Grande do Norte, and he's asking me to ask you, so you both can answer this. He's asking about since we're talking about chipping of the porcelain over the zirconia, and I also would like to know how I'm missing one bullet in your conclusions regarding the interaction of your graded material with the porcelain. How, if you tested that, how does your graded core interacts with the porcelain? If you are looking into that of chipping, but what Rodrigo is asking is about if we need, because now they have new technologies like the CAD-on, like you CAD-cam the veneering material, and then there are many ways to connect the core with the veneering.
Some people are sintering, some people are gluing them together.
Yeah,
I guess
so
my comment,
he's asking what do you think about it, and then you can answer.
My criticism of you, and I think very highly of what he's doing, and he's a good friend, and what he's doing is a very, very good idea. The chipping on the surface, we've seen this incomplete Hertzian cone cracking as part of a wear mechanism on porcelains.